In the last lesson, we reviewed the development history of mobile networks and the service types provided by the current mobile network. Looking into the future, let's explore new requirements and services of mobile networks. Now, smartphones are becoming more and more popular with the diversity of services and applications. However, some services and applications cannot be supported by 4G networks. These include 4K and 8K video, augmented reality or AR, virtual reality or VR, Internet of Vehicles or IoV, and others. They define the development trends of mobile networks. What are their trends? We will tell you one by one in this lesson. The first trend is the increase in data traffic. The explosive growth of mobile data traffic requires a higher rate of the mobile network. For example, it takes 70 minutes to download an 8 GB HD movie using a 3G network at a download rate of 14 megabits per second. 7 minutes using a 4G network at a downlink rate of 150 megabits per second. However, 7 minutes remains a long period of time. Customers require a second-level download experience. Therefore, the downlink rate must reach 10 gigabits per second or higher to provide a better service experience for customers. Let's look at a killer application of mobile broadband in the future: VR. In recent years, VR has become increasingly popular. Many internet companies and technology giants have been engaged in the VR development. In the future, the VR application scope will further expand and VR will apply to various fields such as entertainment and education. At the Mobile World Congress (MWC) 2017, many large automotive companies used VR to present their products and solutions. VR enables viewers to understand the highlights of their automated driving cars more immersively. This indicates that the live VR has become a new form of demonstration for exhibitions and press conferences. In the future, more industries and enterprises will use VR to present their solutions and products. VR services will increase video traffic and require a higher data rate. The ideal VR experience requires a data rate of 2 gigabits per second, which is not supported by the 4G network. The second trend is the increase in the number of connections. With development of smart cities, there are more and more connections on our networks. In addition to people's connections, people and things are gradually connected. Water meters, gas meters, and street lamps can also be connected to the network. This requires the capability of mobile communications to connect more things. Although 4G can enable each cell to provide thousands of connections, it cannot meet the connectivity needs of everything in a fully connected world. In the future, the number of connections per square kilometer will reach 1 million, which is an exponential growth. The connection will penetrate into all fields of the society in the future, namely Internet of Things. From the connection between people to the connection between people and things, as well as the connection between things, the whole society will be transformed through mobile interconnectivity, greatly improving social efficiency. The future network will have hundreds of billions of intelligent nodes. All things in our lives will be connected, including our glasses, watches, and shoes. Additionally, the connections of transfer boxes, forklift trucks, and robotic arms will bring benefits to industrial applications. The third trend is the diversification of service scenarios. Traditional mobile networks provide basic voice and data services. However, future mobile networks will gradually expand to various areas of daily life and social economy. Take automated driving as an example. Internet of Vehicles-based automated driving requires an efficient coordination between vehicles and infrastructures. This imposes high requirements on latency. For automated driving, the latency of the mobile network must be limited to the millisecond level to ensure security. In this way, automated driving vehicles can quickly start the braking system to maintain a safe braking distance when encountering an emergency. In the future, the mobile network needs to offer an ultra-low latency of milliseconds, which will increase the response speed of the mobile network by dozens of times more than that of the 4G network. To summarize, mobile networks are expected to provide a high-rate, massive connectivity and ultra-low latency, thereby supporting new services and applications. The 1,000-fold growth of mobile data traffic, hundreds of billions of connections, and ultra-low latency required by the Internet of Vehicles are the development trend of mobile networks and the problems to be solved on these networks. Facing these service development trends, we need a next-generation mobile communications network. That is, the fifth-generation mobile communication system, or 5G. Who defines 5G? Since 2012, the International Telecommunication Union, or ITU, has been carrying out a research on 5G vision and technology trends in the industry. In October 2015, during the World Radio Communication Conference 2015, held in Geneva, Switzerland, ITUR, the Radio Communication Department of ITU, officially approved the resolution on promoting the future 5G research process and formally determined that the legal name of 5G is IMT 2020. After 2 years of research, ITU's research on the 5G vision have been essentially completed. 5G is expected to give users information and access to everything as required anytime, anywhere in the future. 5G is an end-to-end ecosystem to enable a fully mobile and connected society. 5G can meet the full interconnection requirements of personal wearable devices, smart home and cloud office, as well as requirements of industries such as agriculture, medical care, education, transportation, finance and environment. In order to achieve the overall vision of 5G and provide the services that cannot be implemented on 4G networks, the ITU defined 3 types of 5G application scenarios in June 2015. They are Enhanced Mobile Broadband, or EMBB, Massive Machine Type Communications, or MMTC, and Ultra Reliable and Low Latency Communications, or URLLC. In terms of throughput, latency, and connection density, new capability requirements are defined for 5G networks, including 10 gigabit per second peak throughput, 1 millisecond ultra-low latency, and 1 million connections per square kilometer. Now, let's look at how these 3 types of application scenarios will change our lives. The first is the EMBB scenario. The peak rate of 10 gigabits per second on the 5G network enables us to access the network anytime, anywhere, with a high rate and enjoyable new services such as VR and AR. You can also share what you see through the 5G network anytime, anywhere. You no longer need to worry about sending videos at a concert. The MMT scenario mainly involves massive connectivity, enabling all the things in the entire society to be perceptible. The 5G network supports up to 1 million connections per square kilometer. In this way, our personal wearable devices, smart home devices, and smart city devices can easily access the network to enable a smart life. The shared bicycles, water meters, gas meters, and street lamps can also access the network and provide customized services for users based on connections. Finally, let's learn about URLLC scenario. With the ultra-low latency of 1 millisecond on 5G networks, we can experience the convenience brought by telemedicine and automated driving, and make smart industrial manufacturing a reality. Based on the URLLC application scenario, automated driving and smart manufacturing will be important applications of 5G in key vertical industries. By the end of 2017, Huawei Wireless X Labs signed a Memorandum of Understanding, or MOU, with multiple global industrial robot and automobile companies to jointly promote the development of 5G in vertical industries. 5G will penetrate into various fields of the society in the future and build a user-centric comprehensive information ecosystem. Currently, the global industry has reached a consensus on the characteristics of the 5G system. The system meets diversified service requirements and applies to multiple scenarios. On the basis of the 4G system, 5G greatly improves user experience and implements optimal resource configuration. This lesson describes the development trend of mobile services and 3 types of 5G service scenarios: eMBB, MMTC, and URLLC. In the next lesson, we will discuss 5G protocol standardization and deployment progress.